Hello everyone, this is Anthony Wyckoff with Embrace Tutoring, and in this video we'll be covering SAT Math Practice Test 9, Section 3. Please remember these videos provide additional explanations and content review, but you'll always want to attempt the problems independently. Please feel free to subscribe to our YouTube channel page and ask questions along the way. Okay, so let's get started. Now, before we begin, we want to really understand how to best approach and tackle the SAT math problems, essentially how to think about them. One major tip that we will tell you is that everything is there for a reason or for a purpose, so your overall goal is to always figure out how to utilize the given information. So the three-step process that we're going to use in order to break this down is step one, you always want to be able to read the problem and identify the type of concept being assessed, whether it's circles, ratios, linear expressions, exponents, etc. You then want to be able to evaluate what is given in the problem and think how you can utilize the given information to answer the problem. And then finally, you always want to be able to solve the problem by connecting the given information to the necessary math computations, such as formulas, equations, inequalities, etc. But always remember, everything is there for a reason, and you're going to want to do your best in order to connect what they're asking you to solve for to what is being provided or what is given. All right, so let's move into the test. So first you'll start out with section 3, non-calculator. Here you'll have 20 questions altogether. And moving into question 1, here I see for the systems of equations above, what is the value of x plus y? The first thing you want to come across is that these systems of equations are going to be stacked, which is a telltale sign of the fact that you're going to have systems of equations. So what I'm going to do is I'm going to move the equations over in terms of writing space, and I can either use elimination method or I can use substitution method. In this case, because of the fact that I only have a singular x here with my coefficients, I'm actually going to use substitution method. So I'm going to take my bottom equation and I'm going to plug it in here for x equals 4 minus 2y. And the reason why I'm doing this is because I'm then going to take my x here and I'm going to plug it into my other equation, or basically substitute it into my other equation. And when I do this, I then get 2 times 4 minus 2y minus y equals 8. And when I do this, then when simplified by distributing the 2, I get 2 times 4 gives me 8, and then 2 times minus 2y will give me minus 4y. So I get 8 minus 4y minus y when I bring this y down, and then this will then give me 8. So overall, when simplified, I'm going to get 8 minus 5y equals 8. I'm then going to simplify, and I'm going to get negative 5y equals 0. And finally, then I get y equals 0. But remember, the question is really asking you, what is x plus y? So I now have to plug this back in order to solve for x. So when I plug this in, I'm going to get x plus 2y equals 4. So now what I'm going to do here is plug this back in to one of my original equations. I'm going to get x plus 2y equals 4. Remember, I'm going to plug in my y equals 0 here. So I get x plus 2 times 0, which this will simplify and then give me 0. Right? So then I will end up getting x equals 4. So my overall question is asking for what is x plus y. So hopefully you can tell that y equals 0, x equals 4. The sum of these things together are going to be 4, right, x plus y. But always remember to not make a careless mistake and just simply circle what is asking you to solve for. And then when x plus y, I'm going to get 4 plus 0 equals 4. So B will be my final answer. Now moving on to problem 2. Here I see which of the following is equivalent to 2 times x squared minus x plus 3 times x squared minus x. And I see here these are also like terms, but what I could do is simply distribute these through. And when I distribute, I'm going to get 2 times x squared minus x. And when I distribute this, I'll get 2x squared minus 2x plus 3x squared minus 3x. And then I want to simplify and combine my like terms. And once I combine my like terms, as you see here, then what I'm going to end up getting is a 5x squared, and then I'm going to combine my other like terms, and I'm also going to get minus 5x. So my answer should be 5x squared minus 5x. I'm going to go and check my answer choices to see if any of those reflect that, and they do. So A will be my best answer. Now, moving into problem number 3, it says which of the following statements is true about the graph of the equation 2y minus 3y equals minus 4 in the xy plane. And because of the fact that there's a lot of information here, I want to sort of skim my answer choices in terms of the wording to understand better what I'm supposed to look for. And I also see here that I have a slope-intercept form. And because of the fact that I have a slope-intercept form, I'm going to rewrite my equation for my 2y minus my 3x equals negative 4. And when I rewrite this, what I'm trying to do is solve for my slope-intercept form to get it basically to be y by itself. And here I have 2y equals positive 3x, right? When I bring this minus 3x over to the other side, minus 4. And the reason I'm trying to do this is because I want it to be y equals mx plus b. So now I'm going to divide everything by 2, right, as if 2y, right, divided by 2, because I'm trying to get y by itself. So now I have y equals 3x over 2 minus 2. So hopefully you can tell that this here is representing your m, right, for y equals mx plus b, right? So this is going to be a slope here, and that tells me I'm going to have a positive slope, and I'm actually going to have a negative y-intercept because my y-intercept here is representative as b. So my answer choice should say a positive slope and a negative y-intercept, given the fact of the terminology of what I see here. So yes, my answer is then going to be D because it has a positive slope and a negative y-intercept, which is what matches up what I've come to discover. Problem number 4, the front of a roller coaster car is at the bottom of a hill and 15 feet above the ground. If the front of the roller coaster car rises at a constant rate of 8 feet per second, which of the following equations gives the height in feet of the front of the roller coaster car s seconds after it comes up the hill? Now, I do quickly notice that all of these are in h equals, h equals, h equals, and I can kind of quickly tell that I'm solving for what the height here in given feet. Now, because of the fact that I want to solve for what the height is, I also want to notice that here that I have a rate, right? So my rate equals 8 feet per second, and I notice my rate will always have a numerator over some sort of denominator in terms of units. And my initial height is going to be 15 feet because that's what they're telling me. It says the front of the roller coaster car is at the bottom of the hill and is 15 feet above the ground. So my initial height is going to be 15 feet. My rate is going to be 8 feet per second. And my overall height, I'm not fully aware of yet. So using this information, I can now sort of start to plug things in and figure out what's going to happen. Now, by following the units, hopefully I can tell that my height here is going to be 8 feet per second, right, times seconds, which is almost what s is going to be, right? So here I have my s, because it says gives the height in feet of the front of the roller coaster car s seconds after it starts up the hill. And this is my initial. So by following the units, I can tell that if these seconds were to count, as you can see, then I'm going to stay in units of feet. So height will be in feet, my initial rate or my numerator will be in feet, and then also my in this case, my y-intercepts will also be in feet, right? So for the 15 feet. So once that takes place, then I notice that my answer is going to be A for h equals 8s plus 15. A quick way of identifying this problem, like really quickly, is just understanding that and sort of following the units to make it kind of line up. And also understanding that the 8 feet per second is immediately going to be referring to a rate. So that rate is always going to be attached to some sort of variable. And that variable is going to be the unit here, right, in terms of the numerator as well as the denominator. These will end up canceling together, and that's always the fastest way to try to do these problems as you're solving and kind of creating an equation on your own. Okay, so for problem 5, it says, I notice that here I have a quick equation, C equals 75H plus 125. It says the equation above gives the amount C in dollars an electrician charges for a job that takes H hours. Mrs. Sanchez and Mr. Rowland each hired this electrician. The electrician worked 2 hours longer on Mrs. Sanchez's job than on Mr. Rowland's job. How much more did the electrician charge Mrs. Sanchez than Mr. Rowland? Now, what we want to understand is this is how much more did the electrician charge Mrs. Sanchez. So your value for Mrs. Sanchez should be greater than your value for Mr. Rowland. And it also says the electrician worked 2 hours longer on Mrs. Sanchez's job, but it doesn't tell you exactly the amount. So what you're going to really need to do is essentially just kind of choose numbers. So you want to try your best to keep it easy, right? Here I have C equals 75H plus 125 because this is the equation that corresponds to both of Mrs. Sanchez's job as well as Mr. Rowland's job. And now I just want to choose two values that are going to be separated by 2 hours. So I'm going to choose 1 hour as if in terms of, let's say, Mr. Rowland's job, and then I'm going to choose 3 hours because that's Mr. Sanchez's job. Notice these are separated by 2 hours. So I'm going to plug in 1 here to the initial equation, which is going to be C equals 75 times 1 plus 125, and then that's going to end up giving me my 75 plus 125, which will give me C equals 200. So this is the total cost it for Mr. Rowland's job, assuming that they only did 1 hour of work, right? Assuming in this case that they're only doing 1 hour work. Whereas if I move over to Mrs. Sanchez's job, right, because 3 hours, notice it's 2 hours longer than Mr. Rowland's job, this is then 75 times 3 plus 125. Well, 75 times 3 is 225, and then plus 125 is going to give me 350. Now the question is, once again, it's saying how much more did the electrician charge Mrs. Sanchez and Mr. Rowland? So what I want to do is I want to take the difference between these two things. And when I do that, I'm simply going to, when I solve for the difference, I'm just going to end up doing 350 minus 200, and that's going to be me 150. That's going to be the difference in terms of the price. So $150 is going to be my answer. So C is going to be my best answer. Now, problem 6 states, the circle above has center 0, the length of arc ADC is 5 pi, and x equals 100. What is the length of arc ABC? So here I have arc ABC. Notice it's the other side of the circle, and I notice ADC is kind of the remaining piece of the circle, and this entire thing altogether, ABCDA, is the entire circle. And them telling you that this is the center is just following sort of circle theorems, and that OC is a radius and OA is also a radius. X here is in degrees, so that's going to be more related to 360 degrees. And whenever you see pi, you want to start to also think of circumference, just in case if they ask you for that in any way. Now, it is saying what is the length of arc ABC. So the length of arc ABC here is this outside. So ABC is going to be the outside piece, right? It does tell you that X is 100 degrees. So because of the fact that arc ADC here is equal to 5 pi, and that is also equivalent to 100 degrees, that means that ABC is going to be proportional to the rest of the circle, right? And the rest of the circle is going to be the 360 excluding the 100 degrees, right? Because the whole circle, arc ADC plus arc ABC, and is going to equal the entire circle, right? And the entire circle is 360 degrees. So arc ABC is going to equal, we don't exactly know what pi, but it's going to equal 260 degrees. And the way that we're getting 260 is simply by taking the difference. We're doing 360 minus 100, and this is the remaining sort of degrees here that's proportional. Now, what I can do is when I set up my proportion, I'm going to end up getting 5 pi over 100 degrees, right? And this is for my arc ADC, and then this is going to be equivalent to a certain amount of pi or radians over my 260 degrees, right? And this is my remaining of the entire other section of the circle. Now I'm going to cross multiply 260 times 5 pi and 100 times question mark pi. And when I end up cross multiplying these things, then I'm going to get 5 pi times 260, right, equals question mark times 1. Now, after cross multiplying and dividing, what you'll notice is that you'll get 5 pi times 260 degrees over 100 degrees equals question mark pi times 100 degrees over 100 degrees. Hopefully you can quickly understand that the 100 degrees will cancel, which is good because you're trying to look for the remaining length of the other side represented by ABC, right? Once again, this is proportional to the 260 because I've already removed my 100 degrees. And then now one quick tip I'll tell you, because of the fact that we're in the non-calculator section, is you want to do 260 divided by 100, because rather than multiplying all this out and then dividing by 100, it's just easier to see if you can simplify it first. So 260 divided by 100 is going to give me 13 over 5. And luckily now my 5's will cancel, right, more readily. So my 5 and my 5 will cancel, and here I have 13 pi. And one other master tip that I'll give you in understanding the answer to this is B, is that you want to pay attention to whether or not the pi is still present in your answer choices. If it is, then this sort of will help you kind of understand what's the best rhythm of things and kind of what's the best problem solving strategy. If it's not, then be prepared to plug in 3.14. Okay, but for question 6, the best answer is going to be B for 13 pi. For question 7, it says, if 8 over x equals 160, what is the value of x? Now, I always want to pay attention to the thing that they want me to solve for. I'm now going to rewrite the expression. I'm going to cross multiply to end up getting 8 equals 160x. And because of the fact that I want to get x by itself, I don't want to make the mistake of redividing by the wrong thing. So instead, what I'm going to do is divide both sides by 160, and I get 8 over 160 equals x. Now, you should be able to tell rather quickly that this is going to be a small number, or less than 1. And there's only one answer choice that's less than 1, just in case you get stuck. But if not, then try to simplify this to make this 1 over 20. And then hopefully you can tell that this is going to then simplify to become 0.05 as they're putting this in kind of a decimal form. So D is going to be my best answer. Question 8 says 2ax minus 15 equals 3 times x plus 5 plus 5 times x minus 1. Now, it says in the equation above, a is a constant. If no value of the x satisfies the equation, what is the value of a? And my key takeaway here is if no value of x satisfies the equation. So what I want to do is I want to rewrite my equation, and I then want to distribute. And when I distribute this, I will end up getting 2ax minus 15 equals 3x plus 15 plus 5x minus 5. And now I can combine my like terms, and I will get 2ax minus 15 equals 8x plus 10. And notice this is kind of the major point here, where it says if no value of x satisfies the equation above. So the trick is, if I keep these terms the same, right, for minus 15 and 10, because these are not equal. If these remain the same, being the fact that they are not equal to each other, then if I make 2ax equal to 8x, then these equations will never be the same, right? What is the value of a? It says if no value of x satisfies the equations above, then if 2ax will equal 8x, then because of the fact that negative 15 won't equal 10, then I can solve for the value of a, right, where this equation would not be equivalent. And hopefully you can tell rather quickly that dividing both sides by x and then dividing both sides by 2, that when a equals 4, that these equations will not be equivalent. So your best answer for number 8 is going to be C, where a equals 4. Your master tip is to pay attention to the fact that if it says if no value of x satisfies the equation above, it means you want to make the other parts of the equation unequivalent and then match up the a's and the x's to become equivalent, because no matter what they do, then the entire equation will not be equivalent. And that's essentially what the question is asking you. Okay, for problem number 9, it says a system of 3 equations is graphed in the xy plane above. How many solutions does the system have? Now the key question here is how many solutions does the system have? And one thing you want to recall is that a solution is a coordinate, in other words, somewhere on the graph, right, in terms of x, y, where all of the lines would intersect on the graph. And looking here, I see here that this looks to be a parabola. Here I have like an increasing linear slope. Here I have a decreasing linear slope. And one of the things that I want to pay attention to is where do all 3 of these intersect? So this linear line and this linear line connect here, which would tell me, and this is also falling on the parabola, so it actually appears as though there's only one point that does this. And at this point, I believe this point, yeah, it's going to be -1 and 3 for the point, so B is going to be my best answer. For problem number 10, I see a very long equation up top, and then it says the equation above is true for all x where a and b are constants. What is the value of a times b? So for a times b, what I want to kind of see if I can do, and I want to see if also if I can break this down in a faster way. And the first thing I notice is that this is foiling, and when I am beginning to foil, right, I'm rewriting my entire equation here, although on actual test day, I would just try to use as much of the equation that's written for me. And I want to notice my ax times my 5x squared is going to end up giving me my 20x to the third, because this is the only way my first times my first would give me the first, right? That's the only way I'm getting 20x to the third. And then I also notice that 3 times 4 would give me my last, so this is a foiled out expression. Now, when I start to foil these things all together, I will end up getting 5ax to the third minus abx squared plus 4ax plus 15x squared minus 3bx plus 12 equals 20x to the third minus 9x squared minus 2x plus 12. Now notice my 12s would actually cancel on both sides, and that's okay, right? in terms of how everything is going to be set up. The one other thing you want to pay attention to is that the 5ax to the third, will equal the 20x to the third. So using this information then and sort of combining some like terms and simplifying, I can figure out what a is most likely going to be. So in this case, a is going to be 4. And remember, it says what is the value of ab, right? A times b in this case. So I quickly know that a equals 4. Now I can plug this back in and then solve for b if I wanted to, or I can try to use the same methodology to see if I can solve for the like term of b, right? And so here I have minus ab x squared, and then here I have 15x squared, and then I hear of minus 9x squared. So what we know is that negative abx squared plus 15x squared should equal negative 9x squared, right? These values on the left side of the equation, given the fact that they're both connected to the x squared, have to equal the values on the right side of the equation, given the fact that the negative 9 is connected to the x squared. So they should be equivalent. Now, when I do this and I simplify and I solve for this one, then what I first want to do is I want to factor. And when I factor this, then I will get x squared multiplied by negative ab plus 15 equals negative 9x squared. I can then now divide, right, by x squared on both sides, which is good, because then I will end up getting ab, kind of. So I get negative ab plus 15 equals negative 9. I'm going to bring over the 15 to the other side, and I'm going to end up getting negative ab equals negative 24. So yes, even though I did end up solving for a in the beginning, because of the way that the question is set up, I technically didn't even need to do this section here, right? Because what I'm going to end up getting now, given the fact that these are connected, is simply that I'm just going to divide both sides by a negative 1, and then I'm going to get ab equals 24. So ab equals 24 is going to be my answer, which makes C my best answer. But as I did for this section or the other section, what you want to do is find and line up the appropriate exponents and what is in front of it, kind of the coefficients and what they correspond to on the other side of the equation. That's the best way to tackle this problem. Okay, for problem number 11, I see x over x minus 3 equals 2x over 2. It says which of the following represents all of the possible values of x that satisfies the equation above. Notice it does say all of the possible values of x. I also quickly noticed that I have a bunch of 0 and 2, 0 and 4, negative 4 and 4, and 4. And what I can do is I can solve. Essentially, I can cross multiply, I can solve, I can factor, and I can plug things in. There might be other instances for other types of problems where I might have to do a quadratic, but because of the fact that I'm probably going to have to plug stuff in anyway, what I'm going to actually end up doing is just plugging things in. And I'm basically going to plug things in and then use process elimination here to tell me which answer choices I should focus on the first. So if I start with 0, because 0 is generally always the easiest, then I'll get 0 over 0 minus 3. Once again, right, I'm plugging these things in for x, right? So 0 over 0 minus 3 equals 2 times 0 over 2. I'll then get 0 equals 0, so that does work. And because of the fact that this does work, C and D will now cancel. Now I'm going to plug in 4, and when I plug in 4, I'm going to get 4 over 4 minus 3 equals 2 times 4 over 2, which would simplify to give me 4 over 1 equals 8 over 2, which, yes, would give me 4 equals 4. So 4 also does work. And because both of these work, then I know 4 has to be part of my answer choices, so B has to be my answer, right? If I needed to, and if I needed to plug it in, I could test out 2 or I could test out negative 4, but understanding I've just used 2 methods to solve, B is going to be my best answer. But you could plug in the other ones too if you wish to double check. Okay, so for problem 12, here I have 1 over 2x plus 1 plus 5, and it says which of the following is equivalent to the expression above for x is greater than 0. Now, there are multiple ways to solve this. For instance, you could like choose a number and plug it in order to verify, but because of the fact, and here's kind of your major hint, that everything here has a common denominator of 2x plus 1, using my answer choices again, using my answer choices as a guide, then what I probably want to do, and something that's a little bit more efficient, is just make this 5, have these both be a 2x plus 1 as my common denominator, because when I add them anyway, I'm going to end up getting 2x plus 1. So when I make my 5 here become a 2x plus 1 with my denominator, what I want to do is also make sure to multiply the numerator by 2x plus 1. So here I have 1 over 2x plus 1 plus 5 times 2x plus 1 over 2x plus 1. And when I distribute my 5, I will end up getting 1 over 2x plus 1 plus 10x plus 5. And now I can combine these, and I'm going to get 10x plus 6. So my overall answer to this question should be equals 10x plus 6 over 2x plus 1. So yes, D is going to be my best answer. For problem 13, it says the graph of the function f in the xy plane above is a parabola, and you can tell by the shape here of the parabola. It says which of the following defines f? And one of the things you want to pay attention to is that whenever you see a parabola, this is always going to refer to the vertex form and specific types of quadratics, right? Now, your vertex form is y equals a times x minus h squared plus k, just as a gentle reminder. You do want to remember that the h and the k here do represent your vertex, which either could be a minimum or a maximum, but it's essentially the point here, right? It's kind of the tip. It's either your min, and like it's as illustrated in this case, if it's opening up, it's going to be your min, or it's a max if it's opening down, right? If it's sort of doing the other formation, the max will appear at the top of the hill. Now, the vertex, which is h and k, are here, which means I now have my vertex as is shown according to this problem. And I can also use my other coordinates in order to plug these in, as you can see, for y, a, or k. So I'm going to plug some of these in here, right, for my 3 and my 1. I'm going to plug this in for my initial vertex. And when I plug in my coordinates, right, in order to first solve for a, and then working back and solving in for the other problems, I'm going to get 5 equals a times 2 minus 3 squared plus 1. Now, this is going to become negative 1 squared. So I'm going to get 5 equals a times negative 1 squared. And negative 1 squared becomes 1. So then I'm going to get 5 equals 1a plus 1. I'm now going to subtract 1 to both sides, and I'm going to get 4 equals 1a. I'm now going to divide the 1 on both sides, and I'm going to get a equals 4. So now that I've actually solved for a, and I also have the vertex, what I can do is I can plug these in here all together for plugging in all of my coordinates for the equation. So what I end up getting is y equals 4 times x minus 3 squared plus 1. The 1 comes from the fact that it's the k, right, here, in terms of my vertex of the coordinate. The 3 becomes from the fact that it's my h, right? And remember, it's minus 3 because here is a positive 3, and I plug it into my equation, which is what makes this a negative 3. And my 4, because of the fact that I've already determined that this is what my a is going to be. So now I've plugged in all of my coordinates. So a is going to be my best answer for this question. So 13 will be a. Okay, so problem 14 says, in which of the following does the shaded region represent the solution set in the xy plane of the systems of inequalities above? Hopefully you can quickly tell that these are systems of stacked inequalities, right? They're one above the other. You also see that all of these lines are linear, which do make sense because these are all a y equals mx plus b linear inequalities. In order to do this and understanding these are linear equalities, the best approach is to simply graph them. And you want to try your best to do y equals mx plus b and actually solving for the slope first. And so that way you can figure out the rise over run given the fact that they are giving you the graphs. And I first want to figure out what is the slope intercept, being the position where x is going to equal 0. And luckily, all the slope intercepts are the same. So here I have x is 0, right, y equals 2, x is 0, y equals 2, x is 0, y equals 2, and x equals 0 is y equals 2. One master tip I will give you is that you want to quickly pay attention to the increments of the units. You don't want to just assume they are both moving in the same. Basically what I'm saying is that here you have 1, 2, 3, 4, right, 1, 2, 3, 4, and it's the same for all of them, 1, 2, 3, 4, right, 1, 2, 3, 4. You don't want to just assume they're all moving the same kind of coordinates or the same level of increments. You definitely want to double check so you don't make a careless mistake. And given the fact that this is 1 over 1, I want to do my rise over run, rise. So I'm going to go up 1, right, over 1, up 1, over 1, up 1, over 1. And same down here. I'm going to go up 1, over 1, up 1, over 1, right, each time. And as I do that, I have all positive slopes each time. But now here's the catch. This is y is greater than, meaning that it will appear above that side of the equation. So it's going to appear on this side of the equation, right? It's going to appear because this is my line here. So it's going to appear above that side of the equation. And when that appears so, right, I'm going to have B and C still being graphs that are kind of corresponding to. Now, I want to do the exact same thing for the other equation. For 2x plus 3y is less than or equal to 6. I then want to simplify here and get my 3y on the one side of the equation, because eventually I'm trying to get my y by itself. So I'm going to get 3y is less than or equal to negative 2x plus 6. I'm going to divide both sides by 3. So then when I'm dividing here, I'll get y by itself. So I'm going to end up getting my 3y over 3 is less than or equal to negative 2x over 3 plus 6 over 3. I then will get y is less than or equal to negative 2x over 3 plus 2. And just like before, I'm going to go to my slope-intercept, which is where you see, right, of where it was before. And now this is negative 2x over 3, so now I want to count down because this is decreasing. So my negative 2x is down 2 over 3, right? And here it would be the same, down 2 over 3. And here the same, down 2 over 3. So all of these are also matching. The only difference is, and the reason why you just saw this pop up on B, is that this is less than. So it will need to appear under your linear line. It will need to appear under your function. Now, the question is asking you, in which of the following does the shaded region represent the solution set, right, in the xy plane? Now, this is the only area here that actually had the double set. So B had this set here initially colored in, which means B is actually my best possible answer for question number 14. For question number 15, it says, what is the set of all solutions to the equation radical x plus 2 equals negative x? And I do see here, and like previous problems, I could solve, right? I could technically get rid of the radical by doing exponents to both sides. I could simplify, I could factor, but then what I'll need to do is I will need to still plug in and I will need to check for my solution. So one thing I will tell you, and here's a master tip, whenever you see a radical and it says what is the set of all solutions, and here's your other major tip, whenever you see brackets or Roman numerals and radicals, it is just always easier to plug in. So when plugging in, I'm going to choose values that sort of make the most sense first. I'm going to plug in negative 1, and when I plug in negative 1, I'm going to get radical x plus 2 equals negative x. I am now going to plug in my negative 1, both in places of my x, and I'm going to get radical negative 1 plus 2 equals negative of a negative. So I will get 1 equals 1, right? Or radical 1 equals 1, and yes, this does work. And because of the fact that this does work, now I'm going to assume that negative 1 is going to be in my answer choices. So I'm going to get rid of D, and I'm going to get rid of C. It could now still be A or B, right? Because negative 1 has to be a part of my answer choices. So now what I'm going to do is plug in 2. And as I plug in 2, I'm going to get my 2 plus 2 here is going to then become negative 2. And then this will then give me radical 4 equals negative 2. But because of my principal square rule on the SAT specifically, what you want to pay attention to is that they generally only fall, according to their principal square rule, into the positive values. So basically what I'm saying is that if you have a radical of something for the principal square rule on the SAT, they always assume it's going to be the positive of that square root. So these things will not actually equal together. And because they won't equal together, now my initial 2 here, right, my initial 2 of what I was plugging in will not be a possible solution. So 2 will not work, meaning that A and C, right, and C we have already voted off before, but A is now not going to be a possible answer choice. So B is going to be my best possible answer for question 15. For question 16, and now we're moving into the open-ended, right? It says, what is the volume in cubic centimeters of a right rectangular prism that has a length of 4 centimeters, a width of 9 centimeters, and the height of 10 centimeters? One master tip I'll tell you in terms of open-ended problems is that whenever you have open-ended problems, they must be positive. This is huge, right? You will not get negative answer choices. You will not have radians or pi in your answer, and you will not have radicals in your answer. You may have something under the radical in your answer, but the radical itself is not possible to be in the answer. Same as pi or radians. And the most important thing by far is the fact that this is going to be positive. So it says, what is the volume in cubic centimeters of a right circular prism? So let's see what a So the volume equation, and usually you can reference this in your reference section of the SAT, but it does say right rectangular prism, right, of a right rectangular prism. So here we are, right? Here's a right rectangular prism in terms of what is like illustrated by the length, the width, and the height of something. And if you're ever in doubt, and if this ever says like something like cylinder, prism, pyramid, right, always go to your reference section first. That's going to be the best place in terms of where you would find these things. And in this case, volume is going to equal length times width times height. So here I have the prism that has a length of 4 centimeters, a width of 9, and a height of 10. So I'm simply going to multiply these things together. So 4 times 9, right, times 10, and right, even doing this 4 times 10, right, is going to be 40, and then times 9 is going to be 960. And it does say in cubic centimeters, which makes sense because centimeters times centimeters times centimeters would be cubic centimeters. So yes, volume is going to equal 360 cubic centimeters. So 360 will be my answer to this question. All right, for problem 17, it says 4x plus 2 equals 4. If x satisfies the equations above, what is the value of 2x plus 1? And I always notice I'm always circling what they want me to find, so that way I don't just solve for x and assume I'm finished. Instead, I always want to make sure that I'm solving for the last kind of step of what the question is asking for. Now, 4x plus 2 equals 4, and I just want to solve for x. So now I'm going to do 4x plus 2 equals 4, and then 4x equals 2, right, by subtracting 2 on both sides. And then I get 4x, right, divided by 4 equals 2 divided by 4. Simplify this, and I will get x equals 1/2. Now I want to plug this in. And when I plug this in, I'm going to plug this into the 2x plus 1. And I will get 2 now times 1/2, right? So 2 times x, which x is equal to 1/2. So 2 times 1/2 plus 1. These will simplify, right? 2 times my 2, right? Or my 2 times my 1/2. The 2's will cancel, and this will become 1. So my overall answer is just 2, right? So 17 is going to be 2. Okay. Problem number 18. In the figure above shows the complete graph of the function f in the xy plane. The function g, not shown, is defined by g of x equals f of x plus 6. What is the maximum value of g? So the maximum value of g, meaning what is the greatest possible value that g could be? And in order for this to be the greatest possible value what g can be, you need to figure out what is the greatest possible value of f of x going to be. Notice what this is illustrated here. Quick tip that whenever you have the f of x or g of x or h of x of any of those things, this is just referring to y. It just asks what's the greatest y coordinate of the graph. And it looks like they all have the same greatest y coordinate, right? When I'm trying to find the highest value of f of x. And the greatest y coordinate in this case is just going to be 2, right? So f of x max is 2 for each of these, which means I'm going to plug in a 2 here. And so if I get g of x equals 2, which is my greatest value of f of x, then g of x is the greatest value is going to be g of x equals 2 plus 6, which g of x will then be 8. So 8 will be my answer to question number 18. Problem 19 states, a triangle PQR has a right angle of Q. If sine of R equals 4/5, what is the value of tan of P? Now, the moment that you see triangle PQR has a right angle, you want to kind of mentally or even quickly write down what is a right angle, right, or right triangle. And your right angle is always representative of your 90 degrees. Here you have triangle PQR. So here's P, here's Q, here's R. Notice my 90 degrees is lined up with angle Q. It does then say if sine of r equals 4/5, what is the value of tan of p? The moment you see sine or cosine or tangent, you immediately want to recognize SOHCAHTOA. And quick recap, sine of theta equals opposite over hypotenuse, cosine of theta equals adjacent over hypotenuse, and tan of theta equals opposite over adjacent. So the question is asking, what is tan of p if given sine of r is going to equal 4/5? So let's break this down. So sine of r means that I'm referring to r, and it means that using r as my reference angle, 4 will be my opposite, which means the side across from angle r here is going to be referred to as my opposite. Now knowing that this is my reference angle, the side across from that is going to be my opposite here. So here's my 4. Now the 5 is always across from your 90 degrees because your 5, or in this case, what is across from your 90 degrees is referred to as your hypotenuse, right? So sine of 4 over 5 means that the side across from R and the side across from your 90 degrees, right? So the side across from R is your opposite, and the side across from your 90 degrees is your hypotenuse. So 4 over 5, sine of R of 4 over 5 means that 4 must be across from R and 5 must be across from 90 degrees. The 3 comes from the fact that I am aware that this is a special right triangle, and hopefully you are too, right? Hopefully you know how to do Pythagorean theorem, or just you kind of have it in your back pocket of what are the special right triangles. But the question is asking you for this. The question wants to know, what is tan of P? So we're using tan of P as a reference angle now, not necessarily R. We know this is 3, 4, 5 in terms of proportion, but I want to know what is tan of P. So the side opposite of P is going to be 3, right? And here's tan of theta, right, equals opposite over adjacent, right? This is what I'm doing here. And then my tan of P is 3, and my adjacent is going to be 4 in this instance, right? Because the 5 will still be across from my hypotenuse. So in this case, I'm going to have tan of P is going to equal 3/4, and 3/4 will be the answer to number 19. Now, finally, rounding it out, here we have problem 20. We have the graph of the linear function f is shown in the xy plane above. The graph of the linear function g, not shown, is perpendicular to the graph of f and passes through the point 1, 3. What is the value of g of 0? Now, let's see here if we can break this down. The graph of the linear function g, not shown, is perpendicular to the graph. What is the value of g of 0? I see. Okay, so what you want to pay attention to is that perpendicular slopes are negative reciprocals of each other. And in order for me to do this problem, what I first want to do is I want to determine the slope of the line that's shown here. So then I can do the inverse reciprocal in order to figure out the slope of the other line. So the line that's shown here using y equals mx plus b, I notice I go down 2 and over 1, right, as I come down. So I go from 3 to a 1, and then I go over 1. So it looks like my slope as I go down 2 and over 1 is going to be a -2, right? -2x plus b. And now what I can do is determine the slope of the new line just using that slope, because once again the relationship is that they are perpendicular. And perpendicular means that the slopes are negative reciprocals of each other. So if I know that -2 is the slope to the line that's shown, then I would do the negative reciprocal of this, which means it's going to be the negative of a negative becomes a positive, and the reciprocal just means I put it kind of upside down in fraction form. So -2, the negative reciprocal of -2 is positive 1/2. So now what I want to do is I'm going to plug in coordinates to solve for b. And as I'm plugging in coordinates to solve for my b value, right, here, I'm going to choose 2 coordinates that might make the most sense, right? And in this case, I'm going to do my 1 and my 3, right? It says in perpendicular, the graph of f passes through the point 1, 3. So here's my x is 1. Here's my y equals 3. So I'm going to plug in these coordinates in order to solve for b. And then what I'm going to do is plug in 0 for x in order to solve for this again, right? Like, what would it be if it passed through this point? Or what would it be if x equals 0? That's what it's asking me to do. Solve for y when x equals 0. So 3 equals 1/2 times 1, which will end up giving me 3 equals 1/2 plus b. And so 3 equals 1/2 plus b. Now what I want to do is subtract. So 3 minus 1/2 equals b. And I will get 6 over 2 minus 1/2 equals b equals 5 over 2. However, remember, I'm not done with the question yet, because what I need to do is actually now plug in x equals 0 and solve for that y coordinate. And here all I did was just simply find the common denominator, solve for b. Now I have 5 over 2. Now, plugging this in, I want to plug in all the coordinates to solve for g of 0, right? So here I have y equals 1/2 times 0, then plus 5 over 2. Now remember, the 0 here is coming from the fact that this is my new input. So this luckily will cancel, right? 1/2 times 0 equals 0, or anything times 0 equals 0. And my y coordinate is then going to be 5 over 2. So yes, my g of 0 is actually going to equal y equals 5 over 2, and 5 over 2 should be my answer. Okay, so thanks for watching, and please remember to contact us at info@embracetutoring.com to set up any personalized private tutoring sessions you would like. Stay tuned for future videos, and best of luck with your studies. We definitely encourage you to visit our Instagram as well as TikTok pages if you have any questions along the way. Take care, guys. Best of luck with your studies.